Geometrical isomerism. What is geometrical isomerism? In 1875, Van Hoff and Liebel recognized a type of stereoisomerism in organic molecules are called geometrical isomerism. Geometrical isomerism is also known as cis-trans isomerism or EEZ isomerism. Geometrical isomers are stereoisomers where the spatial arrangement of atoms or groups around a double bond or a ring in a molecule differs. Compounds having same molecular formula and structure but differ in the spatial arrangement of atoms or groups about a double bond are called geometrical isomers, and the phenomenon is called geometrical isomerism. They are optically inactive due to molecular symmetry. Geometrical isomers exist in carbon-carbon double bond, carbon-carbon carbon-nitrogen double bond, and nitrogen-nitrogen double bonded compounds. They are diastereomers. They have different physical properties and similar chemical properties. Geometrical isomers exist as two forms. They are cis form and a trans form. If the similar groups are on the same side of the double bond, then the isomer is called cis isomer. If the similar groups are on opposite side of the double bond, then the isomer is called trans isomer. Example, malic acid and fumaric acid. In malic acid, the carboxylic acid groups are on the same side, then it is the cis isomer. In fumaric acid, the two carboxylic acid groups are on opposite side. This is the trans isomer. Then 2-butene, cis-2-butene and trans-2-butene. So in this cis-2-butene, the two methyl groups are on the same side, whereas in trans-2-butene, the two methyl groups are on the opposite side. These are some other examples of geometrical isomers. First one is the 1,2-dichloroethane. It exists as cis and trans isomer. In the first isomer, that is the cis isomer, the two chlorine groups are on the same side, whereas in the trans isomer, the two chlorine groups are on the opposite side. Next example is stilbene, cis-stilbene and trans-stilbene. In cis-stilbene, the two phenyl groups are on the same side, whereas in trans-stilbene, the two phenyl groups are on the opposite side of the double bond. Next example is cinnamic acid. In cis-cinnamic acid, the two hydrogen groups are on the same side, whereas in trans-cinnamic acid, the two hydrogen groups are on the opposite side of the double bond. Next example is the crotonic acid. In cis-crotonic acid, the two hydrogen atoms are on the same side, whereas in trans-crotonic acid, the two hydrogen atom groups are on the opposite side of the double bond. Next is the difference between cis and trans isomers. Cis isomer, trans isomer. Cis isomer has same connectivity and identical atoms are on the same side, whereas in trans isomer, the identical atoms are on the opposite side of the double bond. In cis isomer, steric interaction is present, whereas trans isomer, there is no steric interaction. Cis isomer is less stable isomer and trans isomer is the more stable isomer. Cis isomer having energy and reactivity is more. Energy and reactivity of trans isomer is less. Cis isomer has polar molecule, whereas trans isomer has less polar or non-polar. The dipole moment value is higher for cis isomer and the dipole moment value is 0 for trans isomer. The melting point of cis isomer is comparatively low and the melting point of trans isomer is comparatively high. Boiling point of cis isomer is comparatively high and boiling point of trans isomer is comparatively low. Solubility of cis isomer is high, whereas the solubility of trans isomer is low. So these are the difference between cis and trans isomers.